Question number 14 for the free response. This question was finding the area of a composite figure. Area here is made up of a half of a circle with a radius of 8 and a triangle where the base is actually going to be 16 and the height value is going to be 28. So this triangle is kind of turned on its side there, but in terms of figuring out the base and height, we have the base 8 plus 8 is 16 and the height of 28. Well, what is the formula for the area of a circle? Well, area of a circle is pi r squared, but since we have half of a circle, we need to take half of that value. So half of pi times 8 squared plus the triangle, and this was the semicircle. 1/2 base times height, 1/2 16 times 28 gives me an area of 324.513. A lot of us didn't multiply by a half because it's a half of a circle. That's how we can modify this the original formula on the formula sheet to help us find the half of a circle. Question 15 and 16. 15, we're finding the surface area of a triangular pyramid. We have a formula for surface area. For a pyramid, our general formula is 1/2 L times P, which is the slant height times the perimeter, plus the area of the base. Now, with a triangular pyramid, the base value, the area of the base, is going to be calculated using 1/2 base times height. We're going to substitute that value in along with the slant height and the perimeter. So, back to our problem. Surface area is 1/2 L times P plus area of the base, which is 1/2 base times height. I've redrawn the base of this triangular pyramid over here, and we can kind of, once we've redrawn it, we see that all the sides are going to be 10, and this value in the center, which is our height, is going to be 8.7. So labeling here, this is my height value, and then this would be my base value. That gives the area of the base to be 1/2 times 10 times 8.7, which is 43.5. So now we need to go ahead and calculate the perimeter and multiply it by our slant height. We're given the slant height up here. The perimeter of our base, if I'm over here, it's going to be 10 plus 10 plus 10, which is in fact going to be 30. So substituting those values in means that our surface area will be 1/2 times 6.7 times 30, slant height times the perimeter, plus our area of the base, which we found to be 43.5, giving us a total surface area of 144 feet squared. Biggest issue on this problem was the area of the base. We didn't calculate it correctly. Also, we didn't calculate the perimeter. That's all the sides around the base of the figure, so 10 plus 10 plus 10 is 30. Next question, number 16. Find the central angle given the arc length. So we've already looked at the ratio for finding the area of a sector. Let's look at the ratio for arc length. Once again, we have a proportion. We use the ratio of degrees, so the degrees in our problem over the full degrees of 360, set equal to the arc length, the edge of that we are looking for, all over the full edge of the circle or the full circumference, which is the formula 2 pi r. So, using this relationship in our problem, set up the ratio of degrees first. We are trying to find our degree measure here, so that is my unknown in the problem, x degrees over the full 360, set equal to the arc length, which we are also given, over 2 pi times the radius here. The radius is clearly going to be 20. So we are trying to find the degrees over 360 equal to the arc length 25 pi over 2 times pi times the radius of 20. We simply need to cross multiply and then divide by 2 pi times 20. The pi's divide out here. Putting this into our calculator gives us 225 degrees. This is a modification of our normal arc length problems. Normally we're trying to find the arc length, so the unknown is here. However, here we're trying to find the degree measure of our problem, but still set up exactly the same way, using our ratio of degrees to ratio of circumferences. Next question. We're given the two volumes of spheres, which we can set as a ratio. The pi's will divide out. We want to turn it into a ratio of radii. We're going from something cubed down to a single unit of centimeters. Going back to our relationship between ratio of sides, ratio of surface areas, ratio of volumes, we were going from volumes back down to sides. So we are going to go ahead and take the cube root of both our numerator and denominator. So cube root of 64 over the cube root of 729 gives us ratio of the radii 4 over 9, 4 to 9 is what we would go ahead and write into our boxes. 4 to 9, or 9 to 4 in this case. Actually, this said the small sphere to the large sphere, so no, we need to go small number 4 to large number 9. Question number 18. An irrigation system uses a sprinkler pipe 300 feet long. So this is where the radius of the circle is going to be 350. So that's our radius. The pivot's around a central angle of 280 degrees. Due to an obstacle, the pipe can only pivot to 280 degrees. Find the area of the system. So looking at this, we're trying to find this area that is getting watered. So this is a area of a sector problem, a very large sector. Let's look at the proportion. We need to set a ratio of degrees equal to a ratio of areas, the degrees in our problem over the total 360, set equal to the area of our sector over the full area pi r squared. The degrees of our sector is 280 degrees over the full 360, set equal to the area of the sector is what we're trying to find. This is our unknown. We're trying to find the area over pi times the radius of 300 squared. We simply need to cross multiply and then divide by 360. Giving us an answer of x is equal to 7,000 pi feet squared, or the decimal approximation of 219,915.5 feet squared. Most of us who messed this up didn't stack a ratio of degrees to ratio of areas. Some of us used the incorrect formula. We're finding the area, so it's pi r squared, not 2 pi r. Those are the two biggest issues for this, just as an application of our area of a sector problem. Which leads to number 19, which is an application of our arc length problem. A pendulum swings a degree of 20. If the pendulum is 40 inches long, how far does it move? So we're actually trying to find this distance here. As we discussed in class, this is actually the arc length here that we are trying to find. So we need to go ahead and set up a ratio for a proportion for the arc length. Let's take a look and see what that looks like. A ratio of degrees, the degrees in our problem over the full 360 equal to the circumference we're trying to find, the arc length, over the full circumference 2 pi r. Again, we're looking for arc length here, so this will be where our variable is. Back to our problem. And that the sector is a 20-degree sector, so 20 degrees over our total 360. We're trying to find the arc length, so that's our unknown value there, over the full circumference of 2 pi times the radius, which is 40. We just simply need to cross multiply, then divide by 360. X is equal to 40 pi over 9 inches if we're keeping it in terms of pi, or approximately 14 inches if we multiply it out. Again, much like the last problem, some of us did not stack the degrees over top of each other. Some of us used the area formula pi r squared instead of circumference 2 pi r. This is just an application of finding the arc length problem.